Hello everyone and welcome to today's webinar titled Preventing Blackouts, Optimizing the Value of Power Failure Investigations. Before we begin this presentation, I would like to go over a few items related to this webinar platform with you. At the bottom of your screen, there are multiple application engagement tools you can use. All the tools are resizable and movable, so feel free to move them around and, for example, expand your slide area to full screen by clicking on the icons on the top right corner. If you have any questions during the webinar, please submit them through the Q&A tool. You may send in your questions at any time during this webinar, and we will collect these and address them during the Q&A session at the end of the presentation. The resource list tool contains some materials and links related to this webinar, so feel free to download any of those that you may find useful. If you have any problems, you can press S5 on your keyboard to refresh the page, and you can find answers to common technical issues in the help tool at the bottom of your screen. Please be also aware that for this webinar we offer a live translation in Chinese, Korean and Japanese. Just click on the flags to activate them. Okay, let's start. My name is Pieter van der Wielen. I'm Business Director Power Failure Investigations at DNV-GL and stationed in the Netherlands. I'm also part-time professor at the Eindhoven University of Technology on the subject of reliability of grid components. And we have some very interesting speakers for you today from all over the world. We have Fred Steenes, also from the Netherlands. Fred is very experienced in power cables and failures of those. And by the way, also part-time professor. Then from Germany, we have Gunther Lichtenberger, specialist in power systems and therefore the system sides of failures and blackouts. Then a lot further away in Singapore, we have Desmond Ng, responsible for our failure investigations in the Asia Pacific region. Ashutosh Sharma is from our Dubai office and responsible and involved in many failure investigations in the Middle East region. And last but not least, I'm very happy that Thijs Schuring could also join us today. As International Head of Maintenance Strategy, he's responsible for arrangements of failure investigations within TenneT, the transmission system operator in the Netherlands and part of Germany. The contents of this webinar will be as follows. And then we will guide you along three different challenges that are often present during failure investigations and how to cope with them. The first challenge will be about examples on how to find the actual root cause itself of failures and blackouts. Challenge number 2 will be about the need for and how to get access to global learnings on failures. And challenge number 3, we will discuss the subject of coping with conflicts of interest, which is often very relevant in the case of failures, of course. I will then present a small summary and the most important learnings, and we will end this with a question and answer session, followed by a giveaway we will also have for all of you. And I will start with the introduction, which I will keep very short by explaining you that this webinar is hosted by DNV-GL, a global quality assurance and risk management company. We have about 12,000 employees in more than 100 countries all around the globe, providing services for more than 150 years. We have various business units like maritime, oil and gas, business assurance and digital solutions. But the one providing you this webinar is the business unit energy. Of course, in case needed, we can make use of the expertise of the other business units too, which is regularly very helpful for failure investigations too. Now, as we all know, failures can never be fully prevented. Sooner or later, a failure will occur, and then there is often interest in the root cause to determine who is responsible. And then that has to do with the cost for repair or consequences, and regularly this is even having legal implications, or wanting to be prepared for that or avoid that. Sometimes it is also related to safety. What about the similar installed components is then often the question, and reputation may also be at stake. However, failure also offers a crucial opportunity for improvement, to adjust policies for example, quality control or maintenance, but also for the technical side of both the component and the power system level. To explain this, we can look to the general asset life cycle, which you can see on the left. This goes from demands, needs and demands via design, production, installation, operation to the end of life. And we often know that the idea is to learn while going around this circle in order to improve for the next time. But we often forget that in case of a failure, this event becomes the most important event on the complete cycle, maybe to learn from. We are normally all daily directly or indirectly involved with trying to avoid mainly that event from happening. So that is one reason. Now, what we have also experienced is that the root cause of failures can originate from anywhere around this circle. We have seen many examples of components being in operation for more than 10 or 20 years, but failing because of some deviation during installation, or even a small error in production or design. So it is of crucial importance to know exactly where on this cycle the root cause is initiated in order to improve on exactly that spot and actually prevent that from occurring. Now, looking at trends, I don't want to consume too much time in talking about the energy transition, as there are many other webinars focusing on that. But what is important to realize in the context of this webinar is that the changes that result from this can also impact the reliability of components and power systems. We are using the components differently, for example, different loading or different voltage and current patterns, and our power systems do become more complex with newer technologies, of which regularly less is known regarding, for instance, reliability. That, together with the ever-continuing aging, increasing time and cost pressure, an increasing number of lawsuits or the defense against them, makes failures often more complex, and at the same time it gets more important to determine the originating problem with a higher certainty. Well, and that's exactly what this next subject is about, how to make sure the root cause of a failure or blackout is determined with high certainty. On this slide, we see various graphical representations of international known general root cause tools, together with DNV-GL's developed tailor-made methodologies and phased approach for power failure investigation. And the purpose of showing this here is not to explain them in very much detail, but to explain that these can surely help the process of finding the actual problem and making sure nothing important is forgotten to evaluate. It's far too easy for all of us to let ourselves be drawn into a certain direction in order to find the solution to the problem as quickly as possible. And some developed methodologies have strict guidelines on how to avoid exactly that, and making sure that the actual root cause of the problem is found and not the easiest or quickest one. And quite often, that's not that easy. For example, in case of a high voltage component failure, there's often a serious breakdown channel through the insulation, often destroying the tiny, possibly microscopic details we are looking for as evidence for the root cause. But instead of me talking about the developed process and investigation phases, I think it's much nicer to have our experts explaining real-life examples for you, demonstrating this. And for this, I will first talk to Fred Steenis, one of our cable specialists. Fred, welcome to this webinar. Now, I just explained about the breakdown channel possibly destroying evidence. Do you have an example of such a case and how to still determine what has caused the failure?
Thank you, Peter, for this introduction. That was nice. I would like to show a typical example of a cable breakdown where several cable lengths that were produced did fail during the factory acceptance test. And if you look carefully to those breakdown channels with a microscope, so you make slices, the microscopy revealed that some of these breakdown channels showed tiny electrical trees. If you look to the middle picture, you can see those small black channels appearing in the red circle. And that is interesting information because that points towards a potential problem somewhere in the insulation material, and that did drive us towards a further investigation of the insulation material that could help us to indeed find small impurities embedded in the insulation material, but far away from the breakdown channel. And they were so small that if you were not pointed towards something in the insulation material, you would very probably overlook these, but now we were focused on it and found them. And it was clear after some electron microscopy that these were most probably clusters of antioxidants. And that learned us that there was, as a root cause, an issue with the raw material. And well, the most common solution for such a case is a better quality assurance that has to be done at the manufacturer and of the raw material and the manufacturer of the cables. But by the way, note that this is also an interesting case, that the factory acceptance test is a very useful tool to find deviations in your insulation material which are too large.
Okay, this is a clear contribution with very illustrative pictures. Thank you. Now, related to this, we know that failures regularly leads also to fires, sometimes completely burning components or even complete substations. Do you perhaps have an example of such a case, and how to then discriminate what is related to the cause and what is just the consequence of the fire itself?
Yes, that is another case I would like to show you, which is a termination that failed somewhere in the world. And that is gave a big explosion, as you can see in the photo with the fire. On the right-hand side, you can see the termination. But what we learned also is before the breakdown and the explosion and fire happened, people made oil analysis of the oil inside the termination and found that there was clear evidence of some partial discharge activity. That they didn't use, and that was a pity, as I will show you later on. But what we can see now is that if we dismantle the complete component, which due to the fire there was not so much left of the, let's say, insulation material, etc. But what we could see is, and that is the middle picture with the big cable conductor exposed, you can see a breakdown hole, and if you look further into the breakdown hole, and the lower picture shows this, there's a small spot, and experts, both fire specialists and other experts, could help us to identify that that small hole was not the consequence of the fire, but it must have been the consequence of an arc. And if it is an arc, then we know also that the failure started inside the termination and not outside the termination. And also inside the termination, on the inner wall of the insulator, you could see in the lower picture now that there was evidence of electrical activity in the shape of electrical treeing. And altogether, this made it completely clear that there must have been a problem in the oil. But what was that problem? That can have different sources. Well, in the first case, you can consider that it is pollution of oil, like with water or impurities in the oil. But that was not the case, because the cable termination passed the site acceptance test a couple of years ago. So it must have been from something else. Another possibility is that you have too low oil level that is giving this problem, but also, again, the too low oil level was not the case in the start, because it passed the site acceptance test. And that brought us to the conclusion that it must have been a low oil level developed over time, and that is possible if you have a crack in your insulator, and that is in fact what really happened. So there was a crack in the insulator, and well, the solution is for next rounds, have a more careful installation, avoid mechanical stress spots. But also it learned us something else, and that those signals we got from the partial discharge traces found in the oil was a very good help, and that could have prevented the complete failure. And it was an expensive one, as you can imagine. Thank you.
Yeah. Okay, amazing to see how the root cause can still be determined. Fred, thank you for this insight into some interesting cable PFIs. Now let us move to one of our experts in Germany, Gunther Lichtenberger, from our office in Dresden. Gunther, welcome to the webinar. You are expert in power systems. Do you have an example of a case in which not a component, but the power system was the reason for the problem?
Thank you, Peter. Yes, I have an example where we have in the first step a failure of a transformer. It seems that it's really the transformer disturbed with a fire, and the fire was more than half an hour. But when you look in detail, the damage of this transformer was coming from other reasons. What you see is a transformer was installed at a 380 kV network with, you can simplify it, of a distance from an overhead line around about 200 kilometers, and the transformer was installed around about 165 kilometers with a second one in parallel, but which we don't care about in the moment. What was the problem here? The problem was that the breaker CB2, which you see at the bottom, have some mechanical problem, and then they disconnected the line 2 and isolated it. During this, exerted a high overvoltage. Normal operating voltage was 340 kilovolt, and now we come to 540 kilovolt. Then half an hour the voltage occurred. And what was the background of this system power failure investigation was that during the commissioning there was a lot of issues coming up. This means we were also involved during the commissioning because there was wrong protection setting calculation. The protection commissioning was not done in the right way. Also, the handling and construction of the earthing system was really bad. You see, for example, here some corrosion on the screws itself. Additionally, for example, the earthing measurement was not done according international standard. So last but not least, we make a supervision on site and look at the connections of the earthing system and everything. And we see that everything was done more or less correct. So the first assumption from our side was that there can be no explanation, simple explanation that the acute overvoltage come from the earthing system itself. What we do then, we go to simulate the system with EMTP, LTP, and make a simulation on it, and model the switching behavior which happens. And then we see with our simulated results that they fix to the measured results. And the reason was that we have now a ferro resonance between overhead lines. This means we have a capacitive coupling with overhead line 1 and 2, which feed a system which was not in operating the overhead line. And the main reason for this was that there was no transposed overhead line. Thank you very much, Peter, for this short introduction.
Yeah, clear, good example of the fact that the first ID on the root cause is not always the correct one either. Now, we have seen many component failures, even if the cause was somewhere else, as you explained. We also do a lot of large blackout investigations. When there's one in the media, we are often involved. Now, I know that many of them are often too confidential to tell something about, but do you have an example, Gunther, of a blackout case or large outage in the industry of which you are able to share something here?
Yes, I have an example of also a blackout of a refinery where we have really a shutdown of the refinery 3 times in 2 years, and we speak about losses around about 100 million euros. And what was the issue here? The issue was here, normally for a refinery, you need 2 independent infeeding. You see on the right side the 2 infeeding on 220 kV side, substation 1 and substation 2, and says from each substation the different transformer were fed, transformer 202 and 203. And what is the background here? The background is if some transformer failure, they will use a high-speed transfer system which moves to the remaining transformer in a very short time. And in this case, we have some faults on the overhead lines on 220 kV with lightning stroke and so on. This happened 3 times, and 3 times the blackout was coming. Coming back to high-speed transfer system, what is the idea of a high-speed transfer system? High-speed transfer system, the main idea of it is that you have one feeder, which you see on the left tile, which feeds in busbar 1, and the second feeder, which is also feed in a second busbar. Normally, the busbars are loaded with 50%, and if a transformer is failed or the network before, then you use taking over very fast to the remaining busbar. And here for the high-speed transfer system, you have normally some criteria how it be activated. For example, short-time transfer in fast confidence, residual voltage, and long-term transfer. And the main issue is here that with a high-speed transfer system, you will move to the remaining busbar less than 1 second. Don't say that it's the same like an auto transfer system. With an auto transfer system, you have changing over times around about 10, 20 seconds and more. In this case, what I explained before, you see that the actual transfer of the installation was 10 seconds and no voltage criteria. So everybody which know a little bit about a refinery can understand that after 10 seconds, a refinery will not operate. It will be in blackout from refinery. So we make some simulation on the system with dynamic network simulation, and then we define this taking over criteria with residual voltage transfer. And when you move it in less than 200 milliseconds from one busbar to another, then the system will survive. So in this case, the main reason was everything was installed, but there was no detailed understanding of the operating of a high-speed transfer system and the surrounding network. And the system itself has to be looked in as total, not in only on the equipment itself. Thank you.
Okay, thank you, Gunther. So we have seen that in order to get to the root cause of component failures or blackouts, there is clearly a need for both in-depth expertise and a wide area of expertise, both on the component level as on the power system level. And we have also seen that the technical details of the problems are not only electrical, but also, for example, mechanical, chemical, or thermal. It's obvious that this also requires laboratory facilities, and then I'm not talking about laboratories that can perform tests according to standards, but often specific tailor-made test setups. Material identification tests or microscopic inspections are needed to help finding the root cause of the problem. Now let's move to challenge number 2, how to get access to the knowledge obtained from failures elsewhere. Fortunately, the number of serious failures and blackouts is limited in most countries. Statistics, therefore, usually show very high reliability numbers, 99.9 something percentage. This is a good thing, of course. However, this also means that learning from failures within one country or region only, or from only one equipment brand, will result in a hard time building sufficient experience before it's already outdated again. So it's important to take into account what happens also in other regions or in case of other brands with similar technologies as well. And Gunther, since we have you on the line, we know that you do a lot of investigations on blackouts all around the world. Do you have an example you can share from some place elsewhere around the globe where possibly, especially combining the global experience or expertise was important?
Yes, I have here also another example where we combined our experience on the energy side and the people from oil and gas, and also our long experience also to power failure investigation. Here you will see also a blackout of a chemical plant. This chemical plant have 2 blackouts in 3 months during the commissioning or startup phase. This means what happens here. there was a final adjustment during commissioning, and it was found out that the control system and not was synchronized in the right way, that it was not tested in the right way. So during this startup phase, then you have the first blackout. Additionally, what we see on this investigation with our oil and gas people, that the system was really focused on availability, but not on reliability. So after the first blackout, there was also done a power failure investigation, and there was a lot of things coming up, but nobody cares about it. So nobody addressed it in detail and looked on it and care about it. Finally, since it was no other reasons than the second blackout have to come, so in the second blackout, then there was prepared in detail power failure investigation. And here we see that it really was a complex issue between steam and electrical side. It was put everything on high automatization, but it was not tested well done. It was designed but not tested. The documentation was bad, and so on. What you also see on the steam side, that here was a high reliability on the steam side, but on the electrical side it was not given. So only on the electrical side some emergency generator was installed, and what we discussed before also, they use an automatic transfer system, not a high-speed transfer system, which is also a bad issue regarding high reliability. And main but not least, you see also that this discussing with the utility and the chemical plant itself, the disconnecting criterion to go to an island operation was not done very well, because the utility have its own disconnecting criteria. The chemical plant must have his own itself. And so during this not checking this disconnecting criteria, then the blackout was only a final result of it. Additionally, what we see every time with this new greenfield project, that during the start-up phase, everything is compromised. Everybody wants to save time and money. And you will also see that it is not tested very well. It's not very well documented. And so then a blackout must happen. What you really see also here is that the system was put in some cases on high reliability, but finally to get it really to high reliability, you must include some short-term, long-term improvement to get a system with really high reliability. Thank you, Peter, to contribute this.
Okay, good to see this example also from the Americas side of the world. Thanks for sharing this, Gunther. Let's also look at the opposite direction now, Asia. And there we have Desmond Ong from our Singapore office in the call. Desmond, welcome to the webinar. You are responsible for and involved in many failure investigations in the Asia-Pacific region. Can I possibly ask you a similar question? So an example of a case where it was very important to be able to make use of the experience or expertise from abroad? Desmond, we cannot hear you. Can you switch on your microphone or check that? Because we cannot hear you speaking. Okay, if that's not a setting, I think we will have to skip Desmond, and maybe you can check in the meantime, Desmond, while we continue with the next speaker. One of the advantages we talked about was the fact that you can share the experience from all around the world in each and every failure investigation. But one of the things that might also sometimes be crucial is the fact that you can be on site very quickly if you have people available in the region. Now, in this case of the pandemic we see all around the world, it can even be more difficult to travel abroad. So it's even more important to have somebody already in the same country. And for that, let's go to Ashutosh in the Middle East from our Dubai office. Ashutosh, welcome to the webinar. You are involved in many failure investigations in the Middle East region. Now, there must be situations that we can have somebody on site, but it's not the particular expert, which now cannot travel because of the pandemic travel restrictions. Can you tell something about how to cope with that?
Thanks, Peter. As you mentioned that it is very important to have the physical presence after any failure has happened, because evidences and facts are very important to reach to the root cause. And as we have, this is also well realized by the number of utilities in this region. So we have a number of frameworks with the utilities which allows us to mobilize as they notify that failure has taken place. But with the coming up of this pandemic, we have found a solution because the travel restrictions were there, but failures were not stopping, indeed. So what we have done is we partnered with a virtual inspection app. That app, we have taken a license, and what we do is we allow an access to the client. So basically, we have adopted two options here. First, we call as a virtual inspection option with the support of the client, where we brief the client, engineer that how it is to be done. We take a control of his camera through a virtual app or the tab of a smartphone or the tab, and then he behaves like our eyes. So we ask him to go to the failure site, we take the control of his camera, we guide him, and we do a kind of a first briefing session, and then we perform the expert inspection. So expert inspection is being performed basically virtually. And second option, which we have also worked it out, sometimes client is not very much willing to do that, and he asked that, okay, if you have any local office, can you please send someone who can do that? So we call it as a hybrid option. We send our colleagues from the office in that country. They can travel to the site if possible, and then we expert take the control of our colleagues' smartphone or the tab, and we perform the inspection, and it has worked very well. Although we cannot say that that is ideal as expert eyes, but we can see results are very positive. I hope it makes sense.
Yes. And what about the other way around? If a customer would like to witness the activities in one of our laboratories but cannot travel either, how do we solve that? Or wait a minute, I may better ask Fred Steenes from our Arnhem office, which we heard before, as I know that you have done this many times, especially now during the pandemic, haven't you, Fred?
Yes, indeed, Peter. Several occasions happened where we did a full investigation in our local laboratory in the Netherlands, but instead of customers traveling to us with their equipment, they only sent the equipment, and the customer watch our investigation via remote possibilities. It can be any platform, but the nice thing is that they still can control to a certain extent what we are doing, because they can still ask questions to have a closer look to something. It's a bit the other way around, as Ashutosh explained us. But I think it is not only nice during the pandemic situation, but also with the global warming and travel restrictions that will come up in the future related to that. I think it is a solution to invest in and to go on with this.
Okay, thank you. Now back to Ashutosh. Taking this worldwide experience we have now seen from examples of, it's nice to mention that we obviously have internal processes to make sure that the knowledge is obtained from all these locations and it's disseminated internally to enable using that in every next failure investigation. And one of those elements is a database with statistics from which can be learned. Ashutosh, I know you recently made some analysis, which one of our colleagues is actually presenting, I believe, one of these days in the CGRE conference in the Gulf states. Can you perhaps show one or two findings you have made?
Yes, Peter, indeed. The presentation is being done in the GCC CGRE event, which is going in parallel with our webinar. So I would like to talk about the cable systems. And as you presented before, the asset life cycle, the different phases of the asset life cycle, here our comparison to the global numbers and to the statistics of the Middle East are presented on the asset life cycle phase of the cable system. Here you can notably see that there are from design till the aging part is presented in a different numbers, but in the Middle East, the key contribution of the failure is coming from the installation and on the external, production and on the installation. So basically external damages, which is basically is considered because of the faster infrastructure development in this region. We can say that can be one of the contributors for the external damages, because the mapping of the cables or the procedures which are in place are not that comprehensive to determine, and third-party damages to the installations are happening. And second is because of the production, and we can consider that the production enlargement in this region is possibly because of the faster growth, the time pressure and the cost pressure coming up on the systems. I think that makes sense, and it helps us to give a proper recommendations when we use our statistics to present to the clients.
Okay, interesting. Thank you, Ashutosh. Maybe it's nice to mention in this context that the statistics and learnings are not about 5 or 10 investigations. Looking at the numbers, I can share that DNV-GL performs over 200 failure investigations each year. And of course, this data you see here on the slide is blurred for confidentiality reasons. Now, before continuing to the next challenge, let's give another try to Desmond Ng in Singapore, whether we already have a good connection now. Desmond, can you hear me, and can we hear you?
Yes, I can hear you loud and clear. Can you hear me as well?
Yes, we have a good connection now. Desmond, let me ask you that first question again. The similar question as I asked Gunther. Can you perhaps share with us an example of a case where it was important to be able to make use of the experience or expertise from abroad?
Yes, we have an interesting case that happened to a transformer that is in a critical infrastructure. So, and this is not the first time that a transformer actually failed. So it failed in the same station. So that's the result that we actually collaborate and work together with our transformer expert from London, in Netherlands, our office, as to investigate the case itself. At the same time, the root cause, the possible root causes also allow us to go in depth into the system study as well to understand further what is the possible cause. We also work together with our system expert in Singapore as well. Yeah, so with a combination of two system experts, one focusing on the transformer failure and the other on the power system itself, we try to actually perform a holistic investigation for the customer to ensure that they find what went wrong, so that they will actually perform more preventive measures on the existing transformer in this facility itself. Yeah, so indeed, we actually uses a global resource to actually perform such investigation in Singapore.
Okay, clear. So it appears it's more or less always important. Now, we regularly hear and say that one of our advantages of having offices nearby is the fact that experts can be on site quickly too, to inspect the site immediately after failure to ensure that, for instance, evidence does not get lost. But is this also so true in practice in Asia? Do you have a particular case where this was crucial to be on site in the region very quickly after the failure?
Yes, definitely. Especially when the failure has a certain impact to the infrastructure, to the system itself. So for the same case study that I just mentioned, this case study, this particular case, the failure happened, and the customer has some form of urgency because it has a bigger impact to the infrastructure. So knowing that we in Singapore and the proximity to the location of the customer, we are able to respond to the customer within a short period of time. So that urgency actually helps to lift off a certain burden from the customer. At the same time, we have ample time to work together with our experts to deliver a certain approach to help the customer to investigate the failure. So indeed, yes, close proximity to the customer actually helps to relieve certain pressure from them, and then also allow us to develop certain investigation approach solution for the customer itself. Yeah.
Okay, great. Thanks for sharing that, Desmond. Thank you very much. So now we move to challenge number 3, coping with conflict of interest. In most failures or outage cases, there are multiple parties involved. Some examples are mentioned here on this slide, ranging from network owners to manufacturers and sometimes even legal courts. Now, especially in the case of failures with large consequences, not everybody agrees, to say the very least. And this is also logical, as sometimes the stakes are very high and large consequences are depending on the outcome of the investigation. We have regularly discovered design issues in certain components, resulting in the need for replacement of up to hundreds and hundreds of high voltage components, involving huge costs for many failures, with even more costs in case of not being replaced. Costs which no party wants to take, of course. So having a party involved, or preferably leading the investigation, that's fully independent of the outcome of the investigation seems essential. And this is essential to get to the actual root cause of the problem itself, but it also helps a lot for the level of acceptance for other involved parties. And of course, all information needs to be handled with the highest confidentiality. So trust and reputation in this case is also important here. But instead of me talking about this from a DNV-GL point of view, it's much better to ask one of our clients about the view on this from their side. And for this we have Thijs Schuring on the call. Thijs is Head of Maintenance Strategy of TenneT, the transmission system operator for the Netherlands and part of Germany. And in that context, he is also responsible for the arrangements around failure investigations within TenneT. Thijs, welcome to this webinar. Now, from a TSO perspective, do you see what is the purpose? How do you see what is the purpose of having failures in the system investigated well?
First of all, thank you, Peter, for this introduction. So yeah, indeed, why power failure investigations within a TSO? First of all, for us as a TSO, securing the supply of energy is our main objective. And in order to achieve this, risk mitigation in our grid is very important. And that's also where power failure investigations for us play a huge role. Of course, also our main aim is to prevent failures from happening. But as you also stated in your introduction, sooner or later, failures will happen. They will occur. And if they do occur in our grid, then we want to make sure that we do a proper root cause analysis. On the one hand, to give some guidance for reparation, so for repair if needed, and on the other hand, to prevent reoccurrence to happen. So that's one reason why we do power failure investigation. In addition, I would like to mention 2 points. One is that we would like to be transparent towards society and other stakeholders, especially because we are publicly funded. And also, we've developed within TenneT into a learning organization, but that's a concept I will touch upon in a minute.
Okay, can you explain how this is arranged within TenneT?
Yes. Well, just mentioned the concept of a learning organization. Until a few years ago within TenneT, we also did power failure investigation, but then we just used the report to give some guidance for repair, and then more or less the report was archived. Nowadays we act differently with the report, so with the PFIs. What we do is that we look within the scope of the specific situation whether we need to do adjustments in our grid, but we also look in a broader way. So we also look into the rest of our grid if we need to make adjustments. And also we take into account, for example, working procedures or knowledge that's available into the company, and if we need to adjust that as well. So we really use the PFIs in a broader sense than we did into the past. And in order to develop into a learning organization within TenneT, we now have internal and external investigational skills in place. That means more or less in practice that failures based on fixed criteria are investigated internally, and outages are always investigated externally. And for that, we have DNV-GL as a reliable partner for us. We have a framework contract in place. And in that framework contract, we have a 24/7 emergency service availability, which is very important. That was also mentioned before, because in that way you can secure evidence, which is very important in order to do a proper root cause analysis. And the last point is that now we have installed within TenneT a PFI Excellence Committee. The people in this committee are reviewing and assessing all the reports and recommendations, so we can secure a proper follow-up of the recommendations within TenneT.
Okay, clear. Now, you already mentioned the DNV-GL as an external partner involved in this. Can you possibly say something more on why this is exactly needed and what are the benefits of that?
Yeah, sure. I think some of these points were also stressed earlier in this webinar, but also for TenneT that counts, of course. Within TenneT, there's a high need for independency. First of all, of course, we don't want to be a student that marks his own homework, so that's very important. But we also have to take legal aspects into account. You can think, for example, of aspects considering the insurance, aspects considering the remuneration of clients or people or parties that have been affected by outages. We can think of warranty issues that have to be solved because of a failure or an outage. So we really need independency in our reporting. And I think in addition, it's not only independency, but it's also the expertise that DNV-GL is delivering. So you have a high range of high voltage experts available, which can support us in our investigations or give guidance to your own investigation. So that's really important for us to have that secured. And I just mentioned also that there's also a need for availability. So the 24/7 availability of DNV-GL is very important for us. I think we all know that after a component or system has failed, there's a lot of emphasis and pressure on the repair, but it also has a high risk that very important evidence to come to a proper root cause analysis is just thrown away or destroyed. So for us, this availability is also very important. Well, the partnership that we have with you is really trust-driven. And that's also very important because as a client, we need to give you access to specific systems. I mentioned here the SCADA EMS system, for example, but also when there's a need for you interview persons within the company. So we really have to be transparent towards you, but that requires a trust basis to be in place in order to get that done. So that's also something that we really appreciate in our partnership with DNV-GL.
Okay, thank you. That makes that very clear. Now, maybe it's nice to also ask you about an example. Do you perhaps have one that you remember best or had otherwise made a large impression on you?
Yes, I brought an example with me. It's a quite recent example of a power outage in Amsterdam in April 2018. The standard situation was that we had a substation called Belmer Zuid, somewhere in the middle of Amsterdam, and that was supplied by 3 cable connections from 2 directions, and all the cable connections were lost in just a matter of seconds. So we actually lost the whole substation in our grid. Well, that led to an outage that affected 18,000 clients for almost 8 hours. And that was not all. The subsequent voltage dip also triggered availability issues of Amsterdam International Airport. And that's, of course, as a TSO, how you do not want to reach the newspaper headlines the next morning. So you can imagine that there was a lot of pressure on TenneT at that moment, also because there was a lack of redundancy for quite a long period. And I mentioned pressure, but I think a better word is also that people got really nervous at that point. So there was a high need for a root cause analysis as soon as possible. So I think more even than in all other situations in which we rely on power failure investigation of DNV-GL, the pressure was high. But in the end, we managed, and when I mean TenneT and DNV-GL, so we managed to do this. And we found out that the cable joint failed together with the GIS. So the reparation or the repair actions were undertaken, and in the end, the redundancy was restored. So that meant that there was a high relief within the company and outside the company at that moment.
Okay, Thijs, great. Thank you very much for contributing in this part and showing this all from a TSO's perspective. This brings us to the summary of this webinar. We have seen that failure investigations are obviously needed to pinpoint the responsible party, but that they are also crucial to avoid recurrence. This helps to enhance the reliability and safety, and is an essential element in the learning process, as we have seen a few times. Furthermore, we have, mainly by means of real-life examples, discussed some essential elements to ensure getting the most out of failures and blackout investigations. The need for both in-depth knowledge of all power components as well as a thorough expertise in the power systems remains obviously inevitable. A structured approach can help to prevent missing important facts, as the first indication is not always the most important one, as we have seen. Specialized PFI tests are regularly needed, and so are the corresponding laboratories to accommodate that, of course. And we have also discussed independency and confidentiality as enablers to get to the actual root cause, and also to obtain a high acceptance level for other stakeholders, like other parties, insurers, or courts. And last but not least, being able to combine global knowledge and experience enables incorporating these learnings in each next investigation, as we have seen. And we have seen now that during the pandemic, even more, having people in the region together with technology of remote virtual inspections is making certain investigations possible, which otherwise would not be possible at all at this moment. So, in case of a failure, if you forget all about the rest, please remember at least this. In case of a failure, make sure an investigation is being performed and make sure it's done well to ensure the outcome can actually also really help you. Which brings us to the question and answer part of this webinar. And I think I'm not seeing the right slide at this moment. Yes, we are. Question and answer. In this question and answer session, we will try to answer the questions that you have submitted during this webinar via the Q&A tool at the bottom of your screen. During this Q&A session, you still can. So let us see what questions we have. There's one over here. Will I be able to download the webinar itself video after the webinar? Yes, you will be provided with a link to do that, so you can do that afterwards. That was an easy one. Let me see this one. And I think this one was asked during the presentation of your part, Fred. The question is, in a hot oil bath, the cable insulation gets transparent. Can that be used to find electrical trees?
Yes, Peter, thank you. Nice question indeed. Well, the hot oil bath is certainly a possibility, but realize that in a hot oil bath you see an insulation sample with a thickness of about 10 centimeters, and electrical trees can be quite small. So you can get an indication, but making slices around the breakdown channel is often the better way to really see electrical trees and get confirmed. So the better way is make slices, and the hot oil bath can be used, but is a bit uncertain way to see them.
Okay, clear. Thank you very much, Fred. Let's go to the next one. Maybe this one was asked during the presentation of Ashutosh. In the case of a PFI, you can find the root cause, but how do I determine how to further act? Who will be able to help translating that to what I should do or how to implement, etc.? Ashutosh, could you possibly answer that question?
Yeah, sure, Peter. Very good question indeed. And see, basically, once we reach to the root cause, the objective of the failure investigation is to mitigate such failures, or at least to minimize to the possible extent. So from the root cause analysis, we lead to the learnings. So we make the recommendations how to do that. Recommendations can be across the complete asset life cycle, as I discussed before and explained. It can be in the design stage. It can be depending on where we find the root cause, or it is from the installation, or it is from where. Then we recommend accordingly how to mitigate those failures. And also, at times, we are asked to give us the time frame, how long it will take to mitigate. So we do some kind of a process analysis, and that can be a follow-up activity of the failure investigation. I hope I could answer.
Yes, very clear. Thank you, Ashutosh. I have here another one. Another question. Let me see. Does DNV-GL see a lot of failures related to renewables? Interesting one. Of course, important in this time. And the answer actually is yes, we do. Regularly, failures occur in, for instance, export cables to wind farms or inter-array cables in the wind farms, the other equipment like transformers and switchgear inside windmills. We also have investigated quite a few problems related to the controls of the inverters in solar farms. Recently, we also had a failure related to the power towards charging stations, quick charging stations of electrical vehicles. So indeed, failures do occur related to renewables. Sometimes it's just the failures like we see also in normal transmission and distribution grids with similar characteristics. Sometimes we also see that it is related to the fact that there's a bit of cost and time pressure related to sometimes installing these kind of installations. So short answer would be a yes. Maybe one last question to Gunther, I see here. It was related to the your example about transformer case, Gunther, what possible mitigation measures exist against ferroresonance oscillations? That was the root cause of that problem.
Yes, the main root cause of this issue was that the overhead lines around of these 200 kilometers were not transposed. So if you would, we make also simulation and show if the overhead lines will be transposed, then the problem will be solved. But that's an issue which is very expensive and that can be done in short time. Other possibility is to switch transformers without no load condition, also with unloaded transformer to do not switch. It's one simplified. Also, what is a possibility that you do not disconnect any parallel circuits, and other issue is increased losses during switching and include everything switches. There exist 5 or 6 solutions which depends on the costs and the installation possibility, but the main reason was actually the transposing of the overhead lines.
Yeah. And maybe I see we are crossing the limited time we have, but maybe one last question to also you, Gunther. This is a nice one. This one is, are we going to see more blackouts due to less reserve by fossil plants? And that are also less available as there is less money for overhauls. Could you possibly answer that?
Yes, I can explain a little bit. The main issue is when you switch off conventional power plants, you reduce the short circuit power. What everybody knows that the short circuit power will be reduced in the distribution network, the transmission network. So when there will be a voltage dip, then they will be, I would, stronger to the distribution side. So this is one of the main issues. Yeah, between to bring in here this issue of voltage dips and so on. This means the configuration also is a little bit. Every time when you could put in renewables, the network will be optimized. So also N-1 operation is also an issue which is not given. On the other hand, what you will see very often is not the problem of the network itself. It's also the main issue from my side is the engineering itself. This means regarding industrial plants, it's very often the discussion about converter feed drives. Everybody wants to install cheap issues. And so they have no converter feed drive installed with fall-through behavior and so on. And last but not least is also this grid codes, which are sometimes have some special issues. How do you connect power plants, but for special items like in refinery and so on, they do not fix very often. Also for some power plants itself, how the power plant have to behave. So the grid codes itself normally are optimized for normal operation, but to go to island operation, you here see some issues which have to be discussed in detail. Also,
okay, thank you very much. Thanks a lot. I see here a new question popping in. I think many people are still in the call, so maybe we can continue for just a few minutes to accommodate answering those questions. I see here one question I would like to ask to Ashutosh maybe, because we talked about virtual inspections. This question is about that. Let me push it to the slide area. What is the point of having virtual inspection? At the end of the day, technicians have to go to the site, is the remark here. Can you comment on that one, Ashutosh?
Yeah, sure. We understand that technicians has to go to the site and restore the supply as early as possible because that is under a time pressure. But we don't want to lose the evidences and facts because those are the key for the root cause analysis. So the inspection is very important and it should be done prior to losing any events. That is why we always stress that it is better to have a framework and a virtual inspection as soon as possible. I think I could.
Okay.
Yeah.
Okay, great. This is maybe a nice one to ask to Fred, because it is related to fault monitoring systems. The question is, do you see a necessity of fault monitoring systems in the distribution sector to help in RCA, or is it sufficient to live with numerical relays? Fred, could you possibly answer this one?
Question. Well, Yeah, I'm already starting. Fault monitoring systems we have already in the market for power cables, where we not only can monitor partial discharge activity from weak spots, but also a complete fault, and that goes online. The system, by the way, is called Smart Cable Guard. But that is only for power cables where we have the ability to locate things that go wrong. Similar equipment is not in that precise sense available for standalone equipment like switchgear and transformers. Would also be quite expensive. Smart Cable Guard is looking to 4 kilometers in one row, but each transformer, that would be a lot of work, but could be done if you spend some time and money on that.
Yeah. Okay. Great. Still a lot of people in the call, so I'm one or two maybe more questions. This is another one just popping in. There's always a high pressure for PFI when failure occurs, it says here, which is true, as we know from experience. How do we find you fastest? Well, maybe I can answer this one easily myself. The best way to do this is to, and this link is also shared in this webinar, to go to our website, PFI website, and on that website of failure investigations, you also find a telephone number, which you can dial 24/7. So that's will be answered 24/7, and you will find their email addresses, which will end up at PFI experts. In an internal process which you have optimized, so in a very fast way. That's the fastest way to reach us, and that's the fastest way to get the service. Yes, maybe this very last question. I saying this because this is a question that's been asked quite a lot now the last year. Also another one that I can answer myself. Now that DNV-GL has sold the high voltage and high power labs to Chasey, can you still do failure investigations? And this is a logical question to ask. But the answer is a very big yes. People often assume that when we are doing failure investigations, we make use of such very much optimized high voltage and high power labs a lot. But in fact, those labs are optimized to do type tests on cables with very high or all kinds of components with very high power and very high voltage in a good way. Do those specified tests, but often in the case of failure investigations, we don't need necessarily those kind of tests. We need very specific tests, tailor-made tests, for instance, related to material or to aging or to the characterization of materials, or to which is about something which is about microscopy or electron microscopy, or tailor-made tests related to voltage, etc. And those kind of laboratories we actually have as DNV-GL, and we are actually expanding those kind of possibilities. So the labs that are really assisting the advisory services, we are expanding, and we are making more and more use of that one. So I can confirm this answer with a big yes. Okay, we are really running out of time now, so I am pushed to end this webinar. We may not have answered all your questions, but in order to accommodate that, we still have our giveaway, which I promised at the start of this webinar. This giveaway is presented over here on the slide. We offer you a 15-minute discussion with any expert you like about a specific subject related to this webinar you like. In this way, you can still get answers to the questions we may not have been able to answer yet, and which you may still have. To do so, please leave a comment within now and 5 minutes, while this webinar is still open, as stated on this slide. So with the words 15 minutes discussion and your email address in the Q&A tool. So the same tool as you used for the questions. We will then get in contact with you with the answer to your question or schedule a 15-minute time slot with you, whatever you prefer. We will try to address them all, and in case we receive way too much requests to handle, we will draw anonymously. But in any case, if you don't get any reply, you can always fill in the general form at the DNV-GL website to get an applicable response in the other way. And with that, I would like to give a big thank you to all our speakers for today's presentation. And also on behalf of our speakers, I would like to thank our listeners for joining us in this webinar today. And have a great rest of the day. Take care. Goodbye.
Goodbye.